The asteroid belt, located between Mars and Jupiter, is a vast region of space filled with countless rocks and debris. But did you know that this asteroid belt is actually a window into the early solar system? In this video, we will explore the asteroid belt and learn about its fascinating history. The solar system was formed around 4.6 billion years ago from a giant cloud of gas and dust. As the cloud collapsed, it formed a protostar at the center, which eventually became our Sun. The remaining gas and dust formed a swirling disk around the Sun, which eventually coalesced into the planets. However, not all of the material in the disk was able to form into planets. Some of it remained as small rocks and debris, which eventually settled into the asteroid belt. This region contains millions of asteroids, ranging in size from tiny pebbles to massive boulders. Each asteroid is a remnant from the early solar system, and studying them can provide valuable insights into the formation and evolution of our solar system. In recent years, spacecraft missions such as NASA's Dawn and Japan's Hayabusa have visited the asteroid belt, providing us with unprecedented views and data about these ancient rocks. Scientists are using this data to piece together the history of the asteroid belt and the early solar system. In this video, we will explore some of the most exciting discoveries and theories about the asteroid belt. To understand the asteroid belt, we need to go back to the beginning of the solar system. As we mentioned earlier, the solar system formed from a giant cloud of gas and dust. As this cloud collapsed, it began to spin, forming a protoplanetary disk around the Sun. The protoplanetary disk was made up of gas, dust, and small rocks. Over time, these small rocks began to collide and stick together, forming larger and larger objects. Eventually, some of these objects grew large enough to become planets, while others remained as smaller bodies, such as asteroids and comets. The asteroid belt is believed to be the remnant of the material that was unable to form into planets. This material was scattered throughout the early solar system, but eventually settled into the region between Mars and Jupiter. Scientists believe that the asteroid belt was once much more massive than it is today. In fact, it is estimated that the total mass of the asteroid belt is only about 4% of the mass of the Moon. So what happened to all of the material that was once in the asteroid belt? One theory is that Jupiter's gravity played a role in shaping the asteroid belt. Jupiter is the largest planet in the solar system, and its gravity is incredibly strong. As Jupiter formed, its gravity began to pull in material from the surrounding disk, eventually becoming the gas giant we know today. However, Jupiter's gravity also had a significant impact on the asteroid belt. As the gas giant grew, its gravity began to push and pull on the material in the asteroid belt, causing many of the smaller bodies to be ejected from the region. This process is known as gravitational scattering, and it is believed to be responsible for the current structure of the asteroid belt. Today, the asteroid belt is a relatively stable region of space, with most of the asteroids orbiting the Sun in a predictable pattern. However, there are still occasional collisions between asteroids, which can create new fragments and debris. Studying these collisions and the resulting debris can provide valuable insights into the history of the asteroid belt and the early solar system. The asteroid belt is home to millions of asteroids, each with its own unique characteristics. However, scientists have identified three main types of asteroids based on their composition. The first type is known as C-type asteroids, which are the most common type in the asteroid belt. These asteroids are made up of carbonaceous material and are believed to be the oldest and most primitive objects in the solar system. Scientists believe that C-type asteroids are remnants from the early solar system, and studying them can provide valuable insights into the conditions that existed during the formation of the solar system. The second type of asteroid is known as S-type asteroids, which are made up of silicate materials. These asteroids are believed to have formed closer to the Sun than C-type asteroids and are generally younger. Scientists believe that S-type asteroids are remnants from the inner solar system, and studying them can provide valuable insights into the conditions that existed closer to the Sun during the formation of the solar system. The third type of asteroid is known as N-type asteroids, which are made up of metallic materials. These asteroids are believed to be fragments from the cores of larger bodies that were destroyed by collisions. Scientists believe that M-type asteroids can provide valuable insights into the interior structure of larger bodies, such as planets and moons. In recent years, spacecraft missions such as NASA's Dawn have visited asteroids in the asteroid belt, providing us with detailed information about their composition and structure. By studying the composition of asteroids, scientists can learn more about the conditions that existed during the formation of the solar system and the processes that shaped the early solar system. Each asteroid in the asteroid belt is a unique and valuable piece of the puzzle that is the early solar system. Asteroids have been a topic of fascination and fear for centuries. While most asteroids in the asteroid belt pose no threat to Earth, there is always the possibility of a collision. In fact, Earth has been hit by asteroids many times throughout its history. These impacts can have devastating consequences, causing massive destruction and even mass extinctions. One of the most famous examples of an asteroid impact is the one that is believed to have caused the extinction of the dinosaurs. This impact occurred around 66 million years ago and is believed to have been caused by an asteroid about 10 kilometers in diameter. The impact caused a massive explosion, sending debris and dust into the atmosphere. This debris blocked out the sun, causing a global cooling effect that lasted for years. This cooling effect had a devastating impact on the Earth's ecosystems, causing widespread extinction of many species, including the dinosaurs. While the chances of a catastrophic asteroid impact are relatively low, scientists are still studying asteroids in the asteroid belt to better understand their trajectories and potential impact risks. By studying the orbits of asteroids and their potential collision paths with the Earth, scientists can develop strategies to mitigate the impact of a potential asteroid strike. These strategies include methods for deflecting asteroids away from Earth, such as using spacecraft to alter their trajectories. While the threat of an asteroid impact is still a concern, the study of asteroids in the asteroid belt is providing valuable insights into the history and evolution of the solar system. The asteroid belt is a fascinating region of space, filled with countless rocks and debris that provide valuable insights into the early solar system. In recent years, spacecraft missions such as NASA's Dawn and Japan's Hayabusa visited asteroids in the asteroid belt, providing us with unprecedented views and data about these ancient rocks. These missions have allowed us to study the composition and structure of asteroids in great detail and have provided valuable insights into the history and evolution of the solar system. However, there is still much to learn about the asteroid belt, and scientists are planning future missions to explore this region of space in even greater detail. These missions will include sending spacecraft to land on and study specific asteroids, as well as missions to return samples of asteroid material to Earth for analysis. By studying these samples, scientists hope to learn more about the composition and structure of asteroids, as well as the conditions that existed during the formation of the solar system. The study of the asteroid belt is an ongoing process, and with each new mission and discovery, we are gaining a better understanding of the early solar system and our place in the universe. Each asteroid in the asteroid belt is a unique and valuable piece of the puzzle that is the early solar system, and the study of these ancient rocks will continue to provide valuable insights for years to come.